All right, so think about where 170 is. So I'm a visual person, so I'd like to show you this visually. You do not have to graph any of them. Just going to show you how it works. So what quadrant is 170 in? 2. So would y'all say, let's just pretend that it's about right here. Is that okay with y'all? Just kind of have to visualize where it is. So the reference angle is actually in this angle that's terminal side is in quadrant 2. It's just how many degrees does it take to get to the x-axis. All right? So I could go to the x-axis this way, or I could go to the x-axis that way. But they want the shortest distance. So it's distance, so it's always positive. So how many degrees have you got to rotate to get to the x-axis? 10 degrees. So the reference angle, 170 degrees, is 10 degrees from the x-axis. It's a reference, and we're referencing this to the x-axis. So the reference angle for 170 is 10 degrees. 210, let's think about where 210 is. 210 is in what quadrant? 3, so 210, what's right here in the middle? 225. Okay, so it's going to be a little bit less than that. Y'all with me? Just kind of estimating. All right, so this is at 225. We've got to get back to the x-axis. So our reference angle back to the x-axis needs to be the smallest way to get back to the x-axis. So you could go back to the x-axis here, or you could go back to the x-axis here. How many degrees? If you're at 210 and this is 180, how many degrees does it take to get back to the x-axis? 30 degrees. All right, that's all you're doing. Sometimes, if you're not sure, draw a picture. Okay, so let's try to do 3 without a picture. 351 degrees. Visualize that is in quadrant 4. Okay, so would it be quicker to rotate to go back here to the x-axis, or all the way back, back around like that? 351 would be somewhere over here, right? Okay, so it would be quicker to go back here. So how many degrees would it be? That would be rotating all the way back to 360. So how many degrees are you from 360? 9 degrees. All right, so this angle is 9 degrees from the x-axis. The x-axis is your reference point, or your reference line. Okay, questions about 1, 2, and 3, those are all in degrees. All right, you do the same thing when they give you radians. You've just probably got to think a little bit harder about where the angle is. Where is 5 pi over 4? What quadrant? 3 or 2? I heard both of those. 3. 5 pi over 4 is right here, correct? All right, so your reference angle would be going back that way. And if you're given the angle in pi, they want the reference angle in pi. How many degrees have you got to rotate back to the reference line of the x-axis? Pi over 4. Because you rotated all the way to pi, and then you rotated pi over 4 more degrees to get to 5 pi over 4. So if you go back to the x-axis, that's your reference point. Okay? Kind of like if you get lost. Have y'all ever been driving around, you just got lost, and you go, if I can just get myself back to where? Come on, y'all done this before. If I can just get myself back to the square, that's what I was thinking. Get myself back to 72. If I can just get myself right back here, then I'm okay. But if you get out there somewhere, for some reason you don't know how to use Google Maps, I don't know why you get lost anymore if you can't use Google Maps, if you've got Google Maps. So you need a reference point. And that's what these are. They're just reference angles. It just tells you how far we are from the x-axis. 5 pi over 7, what quadrant is that located in? 5 pi over 7. Second. Y'all are scaring me. Okay? So 5 pi over 7. I'm just estimating here. Okay, you're going to have to think a little bit harder about this one. It's not on the unit circle, but I need to get back to the x-axis. That's my reference line. Do not pick up your calculator on this one. Whoever said it is right. 2 pi. Okay, 2 pi over 7. Now think about this. Why is 2 pi over 7 the reference angle? Because you need to add 2 pi over 7 to get to 7 pi over 7, which is pi, or where the x-axis would be. So you have to think a little bit harder. To me, I have to think a little bit harder when I'm doing the pi angles. All right, any questions about those 5? All right, the next angle is negative. That's no big deal. We know what to do if an angle is negative. We rotate in what direction? Clockwise. So 250. So this would be 180. If I go all the way here, that would be negative 270. So negative 250 would just be somewhere like this. Okay? So think about where the terminal side of your angle is. You got to get back to the x-axis. So that would be this degree right here. And how much would that be? This 70. Can y'all think the fact that this would be 20? Does that help? If you rotate to negative 250, you're almost to 270. So that little piece would be 20, but you're going back to the x-axis, so that would have to be 70 degrees. You probably can do 7 in your head. If you rotate all the way around clockwise to negative 359, what would be the reference angle to negative 359? 1 degree. You would be 1 degree from the x-axis. 1 degree from the x-axis. It's much easier to explain that the angle negative 359 is 1 degree from the x-axis. You're just 1 block from the square. Okay? All right. 8 and 9, or 8, is 5.5. There's no degree symbol on that, so that means 5.5 radians. Now this one is weird. Okay? So listen to me. This one is weird, so you could do a couple different things. You could turn 5.5 radians into degrees. Okay, does that appeal to anybody? Y'all want to turn 5.5 radians into degrees? Okay, so how would we do that? We're going to multiply 5.5 radians times 180 degrees over pi, and then some of you are going to like freak out because you're going to go, oh no, the pi's are not going to cancel because there's not 2 pi's. You're right, the pi's are not going to cancel. So you're going to pick up your handy dandy calculator and you're going to do 5.5 times 180, and you're going to hit equal, and then you're going to divide by the pi symbol, and that's going to give you about what? How much? 215 degrees. 315. Be patient with me. My goodness. It's not very nice. I'll get you. Okay? So if you turn that radian into degrees, it might help you. I can show you how to do it with the radians, but what would be the reference angle of 315 degrees? 45? Y'all agree with that? Okay. So here's the deal. If they give you the angle in radians, you have to answer in radians. So that can't be your answer, but you could convert that back to radians. Right? Pi over 4. They probably want a decimal because they gave you a decimal. And you rounded here, which is probably, let's just say pi over 4. They're going to give you a decimal in your answer in the back of your book, and it's not going to be exactly, it'll be the decimal for pi over 4. Y'all with me? So where's my calculator? The decimal for pi over 4 would be about, somebody said it, I'm sure, it would be about 0.78, about 0.79. That's probably what the book is going to have. Now that was the back door, the roundabout back door way to do that one. All right, last one, 553 degrees. All right, let's make that angle smaller real quick. How can I make 553 smaller? Subtract 360, that would give me 193. So 193 would be a little bit past 180, and I need to get back to my reference line, which is the x-axis. What would be the reference angle to 193? How many degrees past 180 are you? 13 degrees. So 13 degrees is your reference angle. Any questions about the, oh, flip it over, we've got 3 more. My bad. Example 10, 11 pi over 4. I believe that's on the unit circle. So let's think about where that's located. 11 pi over 4 would be in what quadrant? Fourth. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Are you sure? No, you don't know what you're talking about. 11 pi over 4 would be 2 and 3/4 pi. So where's that located? In the 1, 2 second quadrant. It would be located right here. All right. What's the reference angle for that angle? Back to the x-axis. In radians would be pi over 4. All right, 17 pi over 3. What's the mixed number for 17 pi over 3? 5 2/3 pi. What quadrant is that angle located? Second. So 5, 1, 4th, 3rd. Why can't y'all agree? This would be 5, and this would be 120. So it's located right here. Who said 4th quadrant? Okay, if you're really confused about that, you could convert it to degrees, but they really don't want you to do that. You ought to be able to graph 5 2/3 pi. So where I'm at right here is, who can tell me how many degrees this angle is that I'm marking? Shout it out. 30 degrees. So if that's 30, and I've got to get back to the x-axis, then back to the x-axis would be 60, but they gave you an angle in radians, so they wanted your answer in radians. So what's the same as 60 degrees? Pi over 3. All right, last one in this section. Negative 17 pi over 6. Negative 6 goes into 17 how many times? 2 with how many left over? 5, 6 pi. So let's figure out where that is. What quadrant is that angle in? Y'all are killing me. Third. That angle is somewhere right here. You're going to go all the way around, and then you're going to go 5, 6 pi, which is almost a pi. So what's the reference angle? In radians. Pi over 6. Some of y'all have lost your unit circle knowledge. Maybe you never learned it. All right, last part of your notes. They're going to ask you to use the reference angle, but when I do these problems, I know what a reference angle is. But to me, I just use the unit circle values. I just find the angle, and I do signs. I do the trig function of whatever they're asking me to do. So I would disregard your directions here, and I would just flat out use the unit circle. So think about where 300 is on the unit circle. Y'all thinking about where that angle is? What ordered pair is at 300? Maybe you should get out a unit circle that you've already filled out at this time because y'all's brains seem to be checked out somewhere. What's the ordered pair at 300 degrees? 1/2. Negative square root of 3 over 2. So this is a unit circle point. This is a unit circle point. So sine is just the y value. Okay, you're not doing over r unless you're not on a unit circle. So here sine is just the y value. So the answer to this would be negative square root of 3 over 2. The idea is not to use any work, but apparently y'all need some work. What is, at 240 degrees, what's the ordered pair at 240? All right, secant is the reciprocal of cosine. So cosine is x. So secant is going to be the reciprocal of the x value, and the reciprocal of negative 1/2 is negative 2. 405 degrees. Is that on the unit circle? Yes. What's the ordered pair at 405? You could subtract 360 to get a coterminal angle to make it a little bit easier. That's 45 degrees. Yep, so that's square root of 2. And I'm just writing the ordered pairs. You really don't even have to write the ordered pairs. You're just using your knowledge about the unit circle. So tangent is y divided by x. So at this point, y divided by x would be equal to 1. You're just using the unit circle. I don't know why they're making you use the reference angle. I just wouldn't do it. So I just say just use the knowledge that you already have. Questions about those three? Is that rain? Okay, so y'all get how to do these? All right, I'm just going to give you the answers to the rest of these. 16 is negative square root of 2 over 2. 17 is undefined. And 18 is square root of 3 over 2. So when the directions say use a reference angle to find these values on a unit circle, just use the unit circle and what you know about sine, cosine, and tan. All right.